Hi everyone, and welcome to today's video where we are going to be dealing with circles. More specifically, we are going to be looking at solving area of circles and then working backwards from area to radius. So you can see we've got two circles drawn, one with a radius already and one with an area. So before we get started, if you haven't already, please like and subscribe to the channel so we can just kind of gauge as to whether or not these videos are working. And here we go. So what you need to remember when we are working with area of circles, it's formulaic. Formulaic means that we are simply just taking a number and we are putting that number into a placeholder. So the formula for area is equal to pi r squared. Now, if we talk a little bit about why it's pi r squared, you can see that what would happen is if we were to take this circle and we were to divide this into very, very small pi pieces, eventually what we would get is something that looks like this. So if I just divide, and continue to divide, I can pull these pi pieces out and I can end up making what would look like a parallelogram. And the smaller that I am able to divide these pieces, it would look something like that. The smaller I'm able to divide these pieces, the more it would shift from a parallelogram to a rectangle. Okay, now if you would like to try that, what I would recommend you do is find a piece of paper, draw yourself a circle, and start to divide it into as many pi pieces as you can. Cut them out, and then once you cut them out, try to rearrange them, and you'll see that the smaller you cut the pieces, the more like a rectangle it gets. Now the problem though is that we know the area of a rectangle is simply base times height. So the area of a rectangle is b times h. However, in this case, we don't have a base or a height when it comes to a circle. And what we can see here is if we were to take and figure out why this works, you would see that the height is the length of the radius. So in this case, it'd be 10 meters squared. So height is equal to radius. And if we cut this circle out and rolled it out into a line, because that's what circumference is. Circumference is just simply a line that is rolled around to give yourself a circular object. If we were to take this and roll it out, this line right here at the bottom is going to be worth half of the circumference. It's half the circumference. So if we think about that mathematically for a second, half the circumference, well, we know from a previous video, and we'll throw a card in the top right-hand corner with regards to circumference, we know that circumference has a formula of 2 times pi times r. And if this line right here is half of the circumference, so let's say it's that, half the circumference, then we would simply take this formula and divide it by 2. If we cancel out those 2's, 2 times pi times r, divided by 2, the 2's would cancel, leaving us with just pi r. So what we have here is we have the height, which is r. Let's see if I can make this a little brighter. We have the height, which is the radius, and then we have half the circumference for this line, which is going to be equal to pi times r. Now, if we took this and put them together, we would have pi times r, or r squared. Pi r squared. Radius times radius would be squared. And that's how we end up getting this formula. So now that we have an understanding of where the formula came from and how the formula works, let's just go plug in some numbers and see how it works. So we already know the radius is 10 here. So in this case, what we're going to have here is area is equal to pi, which for our purpose is going to be 3.14, times the radius, which is 10, times the radius, which is 10. Now, a lot of kids make a mistake here where they think that this means radius times 2. It is not radius times 2. Squared means that what you have here is like a square where you've got 10 on one dimension and 10 on a second dimension, or a base times a height. These are two separate dimensions. And that's where that 2 comes from. It's telling you that the shape had 2 dimensions in order to solve it. So now that we have this, we simply are just going to do the math. We'll do mental math. We'll make it easy. What we'll do is this. 3.14 times 10 times 10. Well, 10 times 10 is 100, so we have 3.14 times 100, or 3.14 times 100 is 314, and in this case, we have meters squared. We need the meters squared part because remember, we took two dimensions, pi r and r, or base and height, if we transferred it into a rectangle, and multiplied them together, so don't forget that it is meters squared. So we'll recap that just a little bit. We looked at the formula itself. Why does area equal pi r squared? We talked about why this, if we cut it into infinitesimally small pi pieces, we could actually make it into a rectangle or a parallelogram. And a parallelogram we know as an area of base times height, 2 dimensions. But because we're not dealing with a rectangle, we're dealing with a circle, we're going to use the measurements from the circle. So the height would be the equivalent of the radius. And this is equal to half the circumference. Half the circumference would be 2 pi r divided by 2, leaving us with just pi r. And that's how we ended up with the formula pi r squared. Then what we do is we simply plug the numbers in. Formulas are pretty easy for us to follow. We just plug in the numbers. Pi we knew. Radius came from the circle, and then if we're multiplying the radius times itself, we simply need the radius 2 times, giving us our total area. So now, let's work backwards, and working backwards means that we're still going to use the same formula, but using the same formula means that we're going to have to rearrange some stuff. So let's grab yellow did yellow work? Yeah, yellow worked, okay. So when we have this formula, pi r squared, if you remember anything about fact families, you can simply switch around the order of what it is you're looking for by making an adjustment to the operation. So area is equal to pi r squared. But if we're looking for, say, radius, we need to use all of this. Oops, I just ran my finger through it. We need to use all of this formula. So we're going to move r squared over to the other side, and we're going to need to move area to the other side. So r squared is the same as area divided by pi. Now we have numbers that we can use again. We have 314 and pi. So r squared is going to be equal to 314 meters squared divided by pi. And what you'll notice here is that we're using the same numbers from this side, but I want to show you something. R squared is equal to 314 divided by pi, which is 3.14. I'll just put that in brackets. We're going to get 100. Now you might think to yourself, well, wait a second, we have a different number here. We had a radius of 10, but this is telling us that r squared is 100. Why do we have two different numbers here? Well, the reason we have two different numbers is because of this guy right here. What this is telling you is that you have an area, r squared, you have an area, this number is made up of 2 dimensions. And when it's squared, we need to think of the shape a square. And a square, as we know, has equivalent lengths on all 4 sides. So in essence, what this means is that this number can be broken down into 2 exact numbers that when multiplied equal this. So on a calculator, you're going to have a button that looks like that. Now yesterday, my guys were thinking about this being long division. This does not mean long division. This symbol right here is the square root button. And square root essentially is when we're taking a square and finding the length of one line. Because if we find the length of one line, we have the length of all the lines. So on your calculator, if you were to hit the square root button and punch in 100, or vice versa, 100 and then hit the square root button, depending on your calculator, you will see that this number gets broken down into 10. And why is that? Well, that's because the length of this side is 10, which means that the length of this side is 10. 2 dimensions, which give us an area of 100. So that times that would equal the area of 100, the space inside. And that allows us to, instead of having r squared, So we have r squared is equal to the square root of 100. R, single r, the root of the square, root meaning that it's just 1, r is going to be equal to 10 meters. And now that we have this, we can see that it is exactly the same as that. Okay, so conceptually, we walked through a lot of stuff here. What I would invite you to do, go back through the video, re-watch it to make sure that it makes sense. If something doesn't make sense or you need more explanation, please drop a comment down below. Don't forget to like and subscribe to the channel. And I think that covers everything that we need to do in terms of area and working backwards from area to find radius. Good luck.